This would actually be a -5, because if I went 1, 2, 3, 4, 5 to get 1. Okay, evaluate another logarithm. I've got 32 to the what power equals 2. This needs to be made smaller, so I really think I need a 5th power. Yep. So the what power equals 1/5. And then 36 to the what power equals 1/6. Well, I definitely need a negative to bring it down to the denominator. And I think I need a -1/2. Last one, 8 to the what power equals 4. Ooh, I don't have an easy answer for that one. Let's see, if I square that, I get 64. And then, so that is, I'm going to erase that question mark for a second because I need to be able to write. I think that would be a squared, and then if I take the cube root of this, I get 4. That one's tricky. So I think the what power equals 2/3. All right, let's do some rules. So this is the important part. This is what we're learning this lesson. So these are properties or rules of logarithms. I have a product property. Remember, product is multiplication. I know that if I have log base b of two things multiplied, I can separate them into log base b of one plus log base b of another. My quotient property, that's division. If I have log base b of m over n, that means that I can do m minus n. Subtraction is your division. Addition is your multiplication. And then power property. Remember, that is anything in the exponential spot. So if I look at this one, there's my exponent. For logarithms, I can take that exponent and drop it in the front of the log, and it becomes this format right there. All right, so let's use some of these rules to solve some problems. Okay, so I'm going to use the fact that log base 4 of 3 is approximately that, and log base 4 of 7 is approximately that to evaluate this logarithm. What I'm going to do here is the quotient property. So I know that log base 4 of 3 minus log base 4 of 7 is going to be the answer to this, because if it's division, I can use subtraction to simplify it. And I'm just going to substitute 0.792 minus 1.404 and get negative 0.612 as an answer. Cool? All right, I only have 3 and 7, but here I'm using 21. That's going to be the same as log base 4 of 3 times 7. So I can switch that into addition. And that gives me 0.792 plus 1.404, which is 2.196 as an answer. Okay, here I have log base 4 of 49. I know that 49 is 7 times 7, so I don't think I need the 3 involved. So I can just take log base 4 of 7 plus log base 4 of 7. 1.404 plus 1.404 gives me 2.808 as an answer. All right, let's practice a few more. I know we just did this, but here's our guided practice. Quotient rule is division. So log base 6 of 5 minus log base 6 of 8 gives me 0.898 minus 1.161. 0.898 minus 1.161 is negative 0.263. 5 times 8 is 40. So I'm going to change this to 5 times 8. So log base 6 of 5 plus log base 6 of 8. 898 plus 0.898 plus gives me 2.059 as an answer. Okay, 64 is 8 times 8. So I'm going to do some shortcuts here. I know I can do log base 6 of 8 plus log base 6 of 8. And I get 2.322. 125. I believe 5 times 5 times 5. Yep. 5 times 5 times 5. So we're going to do this 3 times. Okay, really it's 0.898 times 3. $2.694. All right, moving on. So rewriting expressions, we can use the properties of logarithms to expand and condense logarithm expressions. These are expressions with variables. So we're just going to expand them or condense them. I don't know why I circled underneath. Condense them or expand them. Okay, make them bigger or smaller. So let's expand this. I've got lots going on. I have some division, and on the numerator I have multiplication. Okay, we do have to remember our order of operations. So let's deal with the division first. I have log base 6 of 5x cubed minus log base 6 of y. Now I can do the multiplication, which I'm going to split it right here. Log base 6 of 5 plus log base 6 of x cubed, log base 6 of y. Now I can deal with the exponent, which I drop down in front of the log. Log base 6 of 5 plus 3 log 6x. That's a minus log base 6 of y. I've expanded it as far as I can, and I have my final answer. Which of the following is equivalent to these things? Okay, I need to expand these, condense these. I'm going to do the opposite of the last slide. First, I'm going to hit this, or right here, log base 9 plus log base 2 to the third power minus log 3. Then I'm going to hit the left to right. That gives me log of 9 times 2 to the third power minus log 3. Okay, now I can do the quotient. I need more room. Log 9 times 2 to the third power over 3. Okay, 2 to the third power is 8. 9 times 8 is 72. 72 divided by 3 is 24. And that's my final answer. So that's D. All right, let's practice and expand this one. Multiplication, I'm going to split it right there first. So log base 3 plus log base x to the 4th power. Now I can drop that in front. Log base 3 plus 4 it's not log base 3, it's log base 10 of 3. So you can just say log 3 plus 4 log x is the answer. Now let's condense. Now we're going to go left to right. I can hit this one first because it's a power. So natural log 4 plus natural log 3 to the third power minus natural log 12. Condense these. Log 4, natural log 4 times 3 cubed minus log 12. Okay, do the quotient. Log 4 times 3 cubed over 12. That gives me 9. We got it. All right, this one's super duper handy. The change of base formula. Logarithms with any base other than 10 or e can be written in terms of common or natural logarithms using a change base formula. This allows you to evaluate any logarithm using a calculator. If you notice, the calculator has this button and this button. Okay, this is base 10, this is base e, and that's all it has. So, change base formula. Log base c of a, if you notice the c is the lower of the letters in that statement, which is why it goes in the denominator of your change of base formula. Let's erase all that though, it gets a little messy a little quick. Log base c of a, we can change it to log base b of a goes in the numerator, log base b of c goes in the denominator. Now what would you make b? Well, if I want to use the calculator, I'm going to make b a base of 10 so that I can punch the numbers in the calculator, right? I can also make it a log e if I want. Like here we have log base c of a is log a over log c. I can, well, if I make that a base e, I can use the natural logs. It doesn't matter, you're going to get the same answer, but you want to make your base something that a calculator can calculate. So evaluate log base 3 of 8 using common logarithms and natural logarithms. So I'm going to make that log base 10 of 8 divide by log base 10 of 3. And I can actually calculate that. I'm just going to hand my calculator, pick it up, log 8, close parentheses, divide by log log 3. And I get 1.8927. I can also do natural log 8 over natural log 3. And sort of magically, I would get the same answer. Test it for yourself, it works out. All right, sound intensity. For a sound with intensity I in watts per square meter, the loudness, L of I, of the sound in decibels is given by the function L of I equals 10 times log of I over I initial, where I initial is the intensity of a barely audible sound. An artist in a recording studio turns up the volume of a track so that the sound's intensity doubles. By how many decibels does the loudness increase? It's a very confusing problem if you ask me. But we do know that let I be the original intensity so that 2 times I is the doubled intensity. So the increase in loudness is L of 2I minus L of I. Okay? Okay, that equals 10 times log of 2I over the initial one minus 10 log I over I sub 0. I'm going to factor that 10 out because it's just a lot. Okay, log 2I over I sub 0 minus log I over I sub 0. Now, I can actually elongate those problems. Oops. Okay, here I have multiplication and division. So I'm going to save that 10 out there. And this is going to be log 2 plus log I minus log I sub 0. Okay, minus log I minus log I sub 0. Notice I can distribute this negative into that parentheses, so here and there. That gives me 10 log 2 plus log I minus log I sub 0 minus log I plus log I sub 0 plus log I sub 0 minus log I sub 0 plus log I minus log I. I forgot to close my parentheses. What do I have left? Ooh, it looks like I'm changing colors because I'm almost out of space and it gets confusing. 10 times log 2 is all I have left, right? I can actually calculate that. So 10 times log of 2 gives me 3.01 decibels. Okay, that was tricky. I know. All right, let's use the change of base formula to calculate these. I'm just doing log of 8 over log of 5. I feel like we already did this one. Did we? I don't remember the answer. 1.29 would be our answer. Okay, log of 14. You can do ln. It's going to give you the same answer. So log 14 divided by log 8. And that gives me 1.27. Change of base formula. I love the change of base formula. It's super easy. Okay, log 9 over log 26. 0.67. Log 30 over log 12. .37. What if, in example 5, the artist turns up the volume so the sound's intensity triples? How many decibels does the loudness increase? I'm going with our final answer would be 10 log 3. Okay, our answer to the beginning one was 10 log 2 with all that work we did. If it tripled, it would be log 3, and I'm going to get 4.771 decibels. Daily homework quiz. We made it. Nice work. Go ahead and check these answers if you have time. It's good practice. One more page after this, especially these. These are really good practice. And there you go. Good work.